Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host as always, and welcome to the podcast. Now, before we even get started, we want to pay homage to our sponsor again, because without the generosity of all of you out there that purchase our courses and purchase our swag on Electrician Pride, oh, by the way, is our sponsor for this episode, and the donations that come in for the little flashlights or little screwdrivers, all those things help us offset. And of course, the courses, again, help support the program. But we want to pay homage to our sponsors, so we're going to run that beautiful bean footage. Today's show is sponsored by electricianpride.com. Your one-stop shop for electrician-specific t-shirts, hoodies, phone cases, mugs, die-cut stickers, leggings, and so much more. Featuring unique designs for electricians, journeymen, and master electricians, as well as electrical engineers and electrical inspectors. For more information on all the products that are available, visit us at www.electricianpride.com today. All right, so again, if you want all those goodies, t-shirts, got some neat Tesla designs over there as well that you can check out. So today's episode, we're going to talk about multifamily dwellings, and we're going to talk about 3 or more dwelling units, which are making up what we would call a multifamily dwelling. Not a 1 and 2 family, not a single family, but a multifamily. And a multifamily is made up of individual dwelling units. Okay? So we have 1 family, 2 family, multifamily, all of which are made up of individual dwelling units. Okay? And of course, to be a dwelling unit, you've got to meet the Article 100 definition: cooking, sleeping, sanitation, and living, all those kind of goodies that are rolled into one that would qualify it as a dwelling unit. So we'll assume that that's established. And we want to know, how can we use this optional method in lieu of a traditional method using the Part 3 calculation? And they're very similar, except for the Part 3, you have so many steps that you have to go through. You're very similar in the optional method. And when you're doing the multifamily under 220.84, it is very similar to what you would do when you're doing calculations under 220.82. Only real difference is that you don't have the 40% demand factor, where you deal with the first 10,000 at 100% and the remainder at 40, and then you've got a B and a C, because where you get into the heating and AC and general, very similar. And you could do each individual unit and calculate their units up for those feeders that are going to the individual units. But when we're talking about the overall service or a feeder that is supporting all of these units, I want to be able to have a calculation that allows me to do the overall demand factor for a service. That's basically, more often than not, what we're trying to achieve with a optional method for a multifamily dwelling under 220.84. And so we have 3 or more dwelling units. And so it's very similar aspect to it, but different in its approach. Now, the other way that I do this is we could literally go through, in this optional method here, literally go through each unit. But in this allowance, you're going to see that in 220.84C, which is the calculated loads, the process is very similar. The only difference, again, is we don't deal in that 100, that first 10,000 at 100 and the remainder at 40. We don't do that here. Okay? We get to do this just a little different when we're doing this. Okay? So I'm going to walk you through it so that you can see how it is different than 220.82 versus how it is different here under 220.84. Okay? All right, so first things first, we need to just establish what's in the code. And so let's read it first so we can kind of know what gives us the permission to be able to use this optional method. It says under 220.84A, which is titled feeder or service loads, it says it shall be permissible to calculate the load of a feeder or service that supplies 3 or more dwelling units of a multifamily dwelling in accordance with table 220.84 instead of part 3 of this article if all the following conditions are met. Okay, so first thing we notice right up front is we're doing this for a service. What about the feeder? Well, notice it says the feeder that supplies 3 or more. So we could have a situation where you have a mains disconnect and it continues on downstream, and you have what's called tenant side metering. So you have a feeder at this point, but it ends up breaking into separate meters, and then each tenant has their own, disconnect and everything like that. But that feeder would be seeing the load of 3 or more as well. So again, sizing the loads optionally wise, what's good for the service should be good for that feeder. Now, we're not talking about the individual feeders that are going out to the individual units. Okay, that's typically not what we would do. Now, we would probably stick with 220.82 for the dwelling unit calculation. Okay, all right. So, but we'll look at it in more detail here. Now, it says it shall be permissible to calculate the load of the feeder or service that supplies 3 or more dwelling units of a multifamily dwelling in accordance with table 220.84 instead of part 3, should have maybe said in lieu of, but that's what we used to say, instead of part 3 of this article if all the following conditions are met. So we have 3 conditions in order to be able to even use 220.84. Okay, so we need to see what those are. Number 1, no dwelling unit is supplied by more than one feeder. Okay, so it can only have one feeder going to it. Then you'll have your panel, obviously, in your individual dwelling unit with all your branch circuits coming out of it and whatnot. So again, only one feeder per building. Number 2, each dwelling unit is equipped with electric cooking equipment. Okay, so there's an exception here, but let's explain this. There's diversity with electrical loads, and to use this optional method, it's banking on that diversity. And so it's saying, if all of the dwelling units have electric cooking equipment in it, electric range, cooktop, whatnot, then I can use this optional method. Now, on the surface, you think, well, what if I have a building that has gas ranges or gas cooking equipment? Then I can't use this optional method for sizing the overall service, let's say, because we'll stick with service to make it simple. On the surface, that's correct. However, there is an exception. And the exception says, look, if you do the calculation using the standard method for this building, this multifamily building, and then you do this optional method and you compare the two, but when you're doing the optional method, act like you've got an 8 kW range in every unit, okay? Even though you don't, act like you do. Just humor me is what the code is saying. Just act like you do, and now compare the standard calculation with no electric range to an optional method with a fictitious 8 kW electric range, and then compare the two. And if you do your calculation using 220.84 with the fictitious range versus the standard method, which had no electric range or electric cooking, whatever one ends up being the lesser, you can go with. And that's fine. So while it tells you can't use the optional unless you have electric cooking equipment, you can, but you have to do the calculation as if you did have electric cooking equipment. And you only have to use the 8 kW. So it's basically a fictitious 8 kW in every unit. And then compare the value. Just go in and work your optional method as normal, even though you argue and say, wait a minute, I've got a gas range. Just forget it. Just pretend like it's an 8 kW in there. And do your math as normal. If the value that you end with is less than what it would have been doing the standard part 3 calculation without the electric cooking equipment, then you can go on and still use the optional because it ends up being less. So you have to compare the two. Now, if you have electric cooking in there, then you don't even need to do this. You already meet item number 2, and you can move on to number 3. Okay, but again, it's important that you understand the exception. Okay, now number 3 says each dwelling unit is equipped with either electric space heating or air conditioning or both. Now, I don't know any that are not going to be equipped with air conditioning. I'm just saying. So anyway, so it's got, so it's probably moot here, but I mean, okay, so they can have either electric space heating or air conditioning, or they could have both, okay? And it says, feeders and service conductors whose calculated load is determined by this optional method. And of course, you've heard me say in other podcasts, calculated means after we come up with the final load based on what's in this table 220.84, okay? It says, feeders and service conductors whose calculated load is determined by this optional calculation shall be permitted to have their neutral load determined by 220.61. And if you go to 220.61, that is just, it's in part 3, so we have to give you permission to go back there. But you get to use all the rules that are in 220.61 for sizing the neutral. And it's basically giving you direction where to go because, as you know by now, you don't have neutral sizing rules in optional methods. You have to use the standard methods in order to achieve this goal. Okay? All right. Now, let's go to the next topic. Assume we meet these 3 things, okay? And we can use this optional method in lieu of, or instead of, they say in this one. I guess they didn't like the word in lieu of. Instead of part 3, so I meet all these rules, I check all the boxes. Now, what if I have house loads? Now, I might have common outside lighting, for egress or things like that. Well, the house loads are treated differently, okay? And it states it right here in 220.84b. It says, house loads shall be calculated in accordance with part 3 of this article and shall be in addition to the dwelling unit load calculation in accordance with table 220.84. So remember, for designers, if you're going to use this optional method, you can't use this optional method when it comes to the house loads. And that might be a multitude of things. It might be exterior lighting, parking lot lighting, things like that, if there is parking lot lighting. All of those things that are associated with house loads. And I usually tell people if they're paid for by the ownership of the building on their own separate meter, those are house loads. And you're going to calculate those separately using part 3, which is just your standard method. Now, of course, you're going to add that value to your overall total for your optional method. But again, those are not to be utilized in the optional method. So take those totally out. Don't even ask me the questions like, well, how do I incorporate house loads? You don't. You treat those totally separate as if they were standard. In most cases, the house load's not going to be that much anyway. But just so you know, this reminds you in 220.84b, treat it totally separate. Okay? The next thing you'll look at is you'll see that there's a table, and we're not going to use that table just yet. We're going to go down to 220.84c. Now, this is talking about calculating the loads, and we need to do this in order to determine how we apply the demand factors that are in the table 220.84. And so let's read it. Now, this is where it gets pretty simple because unlike what you do in 220.82, whereas the first 10,000 at 100% and the remainder at 40 and AC, this is pretty cut and dry. And this is the easiest way to do this is just no matter how many units you have, do whatever the values you come up in VA times the number of units, okay, or the number of appliances or whatnot. So I'll kind of walk you through this. In our example, and we won't do the overall math because we just want to kind of talk about generalities. We're going to do, let's say we have a 6-unit, okay, a 6-unit multifamily building. It's got 6 units in it, okay? There's 5 items here. 1, 2, 3, 4, 5. Pretty cut and dry, folks. I'm telling you. First things first. It's a multifamily dwelling, so it says 3 VA per square foot for general lighting and general use receptacles. Okay, so again, what you do under 220.84C1, it's 3 times the square foot outside dimensions of the building, okay, of each unit, okay, individually. Do 1 unit, and then it's times the number of units. So in our case, let's just say, just for craps and giggles, let's say it's a 1,500 square foot unit. So we would do 3 times 1,500 times, and we said we had 6 units, right? Times 6. So that's all you do. So again, 3 times 1,500 times 6 is what? 27,000. Do it again. 3 times 1,500 times 6, 27,000. Now, what was it per each unit? Just so you know, it's 3 times 1,500 square feet. So that's 4,500. So you could do it that way. Once you get 4,500, then you do that times 6, it's 27,000. But for us, we want to have a value when we work through the steps. So the general lighting and receptacle loads are 27,000. Okay? So that's kind of where you would start. Now, the next thing logically is we're going to have the small appliance branch circuits. Now, here's something interesting. The concept is pretty much the same as the standard methods. Okay? It's just a little different, but it's the same mentality approach. At least for the first 3 steps are going to be very similar. Now, once you get past that to the appliances, it changes, but the steps are pretty similar, right? So in this case, the next step, we've got our general lighting and general use receptacles. That was 27,000, for example. Now, it says number 2, it says 1,500 VA for each 2-wire 20-amp small appliance branch circuit and each laundry branch circuit covered in 210.11C1 and C2. All right, so in our case, we know that your code requires a minimum of 2 small appliance branch circuits based on the general rules in 210 for each one of these dwelling units. So we know we got 6 units, but we have to do 1,500 times 2 times how many? 6 units. And that is 18,000. So that would be my VA for the small appliances for all these units. Now you're going to say, how is that true? How do we check that? Well, if each unit has to have at least 2 small appliance branch circuits, and they're 1,500 each, that means each unit has 3,000 VA of small appliance branch circuits. Times how many units? 6 of them. That's where we get the 18,000. So you write that down. So what we're doing is we're kind of doing all the units in a bulk application. Okay? Now, you got the laundry circuit. Same concept. The laundry circuit in 210.11C2, it's 1,500 VA, and you have a minimum of 1. So times 1 times how many units? 6 units. Every unit is identical in this scenario. So 1,500 times 1 equals 1,500, obviously, times 6 is 9,000. So it's 9,000 VA, and that is the first 3 steps to get your general lighting and receptacle loads, your small appliance branch circuit loads, and your laundry branch circuit loads. Okay? And you literally just write those down. Now, after that, it gets a little bit different, okay? Because after that, you start taking all of the appliances, your hot water heater, your dishwasher, your disposal, your clothes dryers, your range, your microwave ovens, okay? And we're not dealing in heating and cooling. We're just dealing in all those appliances and motors that are associated with 220.84C3 and 4, okay? So we're gonna kind of lump 3 and 4 together. So what does it say? Number 3, it says the nameplate rating of the following: all appliances that are fastened in place, permanently connected, or located to be on a specific circuit. Okay, and that's example of like a microwave, specific circuit. Ranges, wall-mounted ovens, counter-mounted cooking units, clothes dryers that are not connected to the laundry branch circuit specified in item number 2. Okay, so again, clothes dryers typically wouldn't, but sometimes you have a combo unit that is designed, small style, that is designed to plug into the laundry circuit, so you wouldn't have to add that here. But most of the time, they're separated, 30 amp. And so, again, if you do have a clothes dryer, okay, then you're going to take that nameplate value, as it says here, and then, of course, your water heaters. Okay? So you have an item 3, and it has a subdivision of A, B, C, and D. And you just literally take all those values. Now, how do you apply them to this? Because this is a multifamily dwelling. Well, we said there was 6 units. So basically every unit's the same. So you take the value in VA from the nameplates, okay? And then if you don't know how to do that, okay, then it's simply the volts times the amps, okay? And that's going to give you your VA. You simply take that and you do it times the number. 6 units is going to be 6 water heaters. 6 units going to 6 dishwashers. 6 units going to have 6 disposals. 6 units going to have 6 clothes dryers potentially. 6 ranges. You see what I'm saying? So you basically, if I just give you an example of one, let's say we have a water heater that's 4,500 watts, which is synonymous with VA, okay, for these calculations. So it'd be 4,500 times 6, 2,700. And that would be the value of the water heater loads. And you do the next the same way for the dishwasher, the next the disposal, the next for the clothes dryer. You just keep on going down the list, okay? Now, the next one is item 4, which says the nameplate amperes or kVA ratings of all permanently connected motors not included in item 3. So we don't want any motors that are associated with anything in item 3. These are separate type of things that might come into play. Separate motors for whatever it might be. Let's say maybe you have some attic fans and the attic fans have motors. Okay, so you're going to encompass that value in there. Okay, in order to come up with a total load is what we're coming up. We're trying to determine our loads that are going to be associated in our calculation. Okay, then item number 5, which again is basically something we're very familiar with. It is the larger of the air conditioning load or the fixed electric space heating load. So you're going to compare the two, and you're going to determine which one is the larger. Now remember, if you have things like your electric heating that's actually going to use the air handler, then you need to include any motors that will also be associated with the air handler. Okay, so just remember that when you're dealing with heat pumps, you want to include the compressor and the maximum amount of electric heat that can be energized while that compressor is running. Okay, so again, just remember that. But for most purposes, for me and you, you're just going to compare the heat versus the AC. And again, you take the larger of the two. Okay, and you throw that into the equation. Now, once you do that, it's pretty darn simple, folks. You just add up all of your VA values. Okay, and then you're thinking, okay, I'm adding up all of my and also I should remind you, when you're doing AC versus heat, remember you still have 6 units. So even though you're calculating it for one, comparing the heat versus AC, you take that value, then you multiply it by the 6 units, and that gives you your total VA. So you literally add all them up, okay? Add them all up. And you put the value down, and you multiply that VA by the demand factor that's in table 220.84. It's pretty simple. So if I have 6 units and I take that total demand, that total calculated load, or I should say total connected load, if we take that total load value, and then notice that 6 to 7, it's 44%. So I can take my total value, okay, and I can multiply it, right? Or actually, you take that total value and you do it by 44%, all right? And that's going to give you your VA. Now, the next step you got to remember, what if you have house loads? If you have house loads, this is the time that you now add your house loads in. But those are based on the standard method. You follow the rules for the standard method. Probably not going to be a large amount of load, but it could be an additional 100 amps. So you want to make sure, or it could be an additional, I should say 100 amps. It could be an additional 100 VA or 250 VA or 500 VA or whatever it may be. You need to add that in. Okay, so we want to know what that value is what you're gonna add in. All right. So one thing I tell people at this point is that you take the VA value from all of the loads that you did, multiplying it by your demand factors. Then you take the VA for the house loads using the standard method, part 3. Okay, you add those two together, all right? And remember, house is done differently. Once you add those two together, then you divide them by the voltage value. If it's a 122 40-volt building, then it's whatever that value is when you add the calculated load that you got from all of the VAs from all the steps you just did, plus you add the VA from the house load, which you used part 3 to calculate. You didn't use the optional method for that. You add them together, and you take that VA value and you multiply it by whatever the voltage is you're working with. If it's a 122 40-volt system, you do it by 240. If it's a 208 3-phase, then you do it by 360. If it's a 480 volt, then you do it by 831. You get me? Okay, and if you ask me how you get those values, then you just simply take 208, times 1.732, and that's where you get the 360. If you want to be precise, you can do it out to the 3 decimal points after the point and whatever, and it's still not going to make that much of a difference. So that's how you do it in order to be able to achieve that. Okay, now I'll remind you, there is not an optional method for sizing the neutral. Okay, there is not. You cannot do it. You cannot achieve it that way. But you can calculate it out, and it's not overly complicated at all. All you have to remember is the loads that you're dealing with. You're only going to take into consideration the neutral loads, okay? And we're not going to go into the neutral sizing in this episode because I don't want it to be overly long. But again, it's pretty simple process to go through, and maybe we'll do that in another episode if you want to figure out how to size the neutral load for that type of thing. Now, I would be remiss if I did not say sizing the optional method for each individual dwelling unit. You're going to use 220.82 to do that. What we did was we sized the actual ability for the entire multifamily structure using the optional method in 220.84. If you want, and people send me enough emails, I will do another podcast on optional calculations for each individual dwelling unit so you can size the feeders that are going out to each individual unit if you feel that that is beneficial to you. Anyway, hopefully you got something out of this episode and it kind of broke it down when you can and when you can't use 220.84. On an exam, it should always be an option anytime they give you a question that has 3 or more dwelling units, because this is what they're trying to target. They're trying to see if you understand how to use this method. Now, on an exam, they'll say not considering optional methods or standard methods. It will tell you. So just read your questions. Make sure. Now, if optional methods are open game, then truly learn how to use 220.84. It is going to result in most cases in a smaller service that is yet still adequate to actually handle the load. Okay? So next time, folks, stay safe. God bless.